Okay, good morning, everybody, and thank you so much for joining us on this beautiful Monday, July 12th of 2021. On behalf of Old Dominion University, welcome to REYES, Remote Experience for Young Engineers and Scientists. My name is Nestor Escobales, and I am a master lecturer in the Engineering Technology Department here at Old Dominion University, known also as ODU. I am a licensed professional civil engineer, PE, with primary focus in structural engineering. I completed my undergraduate education at the Polytechnic University of Puerto Rico and graduate education at the University of Illinois at Urbana-Champaign. My areas of interest are pre-engineered metal buildings, collapse or forensic investigations, and structural mechanics. This presentation is intended for STEM majors. STEM is short for science, technology, engineering, and mathematics. This session deals with experimental testing of metals in torsion, but in a virtual setting. Engineers are required to design safe and economical structures, and for this, we need to understand the mechanical behavior of the elements that we use in design. This knowledge helps engineers make better decisions when deciding which cross-sectional shapes and materials are to be utilized when subjected to different types of loading conditions. It also allows us to understand material behavior like brittle or ductile behavior, among other things. We will start in a few seconds with the presentation in about 30 to 45 minutes. I will switch to questions from the audience. However, feel free to start sending your questions as you listen to the talk. In fact, I encourage you to send the questions over via the chat. I will answer as many questions as possible during the last part of our segment. So again, thank you for joining us. And I am sure that you would find the talk interesting. If you are interested in STEM related, then certainly this would be something that you will enjoy. So on the screen, you should be able to see what is called Blackboard, which is a communication tool that faculty members have to communicate with the students. And it's also a central point where we locate all of the information related to all courses. And that can be handouts, can be excerpts from chapters, can be lecture notes that the faculty member may have prepared, tables, graphs, homework, assignments, quizzes, tests, projects, literally everything that has to do with a course, a semester course or a university engineering course. It is pretty much located in Blackboard. So it's a communication tool that we have between the students and the faculty members. So for this case, what we have in here is a number of files on the left in here. On your side, you're going to see information, thermodynamics, material testing, fluid labs, Excel videos, Python for physics, and help. That's what you will be able to see, which you should be able to see my cursor on the left here moving. Some of you are going to be more interested perhaps in thermodynamics or perhaps in fluids. Certainly, if you register for fundamentals of engineering, then you'll be able to see the three different types of laboratories. One of the questions that we get a lot is, how would you be able to do a laboratory in a virtual setting? Typically, a laboratory is a kind of a hands-on activity, meaning that you have to be present in a laboratory in order to do so. But today, with the advances in technology, we're able to do more things than we used to in the past. So we essentially took a crew, a camera crew, into the laboratory, and we went over all of the equipment in the laboratory, and we recorded literally everything in there in such a way that you could see what would happen in a real or actual class. And so that created, an opportunity. It opened up a window of opportunity for those that, for whatever reason, were unable to be on the campus. And certainly with the most recent situation in last year with COVID, etc., well, this actually worked out extremely well, because we were able to continue offering our courses online and be able to move forward and not just sit back and say, well, what am I going to do now? So we were able to function appropriately and continue the process. So you're going to be able to see thermodynamics lab, material testing lab, fluids lab, and those are scheduled. If you go to the REYES webpage, you'll be able to see the schedule, the calendar. And so make sure that you are aware that we are on Eastern time, so that you can coordinate if you live in a different time zone, so that you can at least watch the live class and be able to ask questions live. The recordings are going to be posted on the REYES website no matter what, and you can still send questions to the REYES website even afterwards, so you're welcome to do that. So one of the first things that you're going to do when you log in is that you're going to see the Blackboard page. Now, what I'm going to do here is I am going to I'm going to send you in the chat a link. Which I would like you to copy. And that link, just copy and paste in your web browser on a separate tab, so that you can access or and so when you click on that link to essentially see now what you have that link on a separate side on the side, and let's continue talking in here. And because believe it or not, I will give you homework today. And so I want you to spend some time, and it's something that you're not going to be able to do it during the presentation. So you're going to have to spend a little bit of more time, and I'm going to offer you some challenge so that we can have, a nice conversation. So when I go into the material testing lab, which is the part that I am in charge, you'll be able to see Professor Nathan Lotke with the thermodynamics lab and Professor Orlando Ayala with the fluids lab. And those are, as I mentioned before, scheduled. So you'll be able to see that on the REYES website. So I'm going to be in charge of the material testing laboratory. So click on that. And you're going to see tension test, torsion test, and you're going to see a civil engineering technology. Well, certainly I am a civil engineer. And I was actually the material testing laboratory director for 11 years, believe it or not. So I was able to do a lot of work in the laboratory with different types of equipment. And in addition to that, I was able to record.
I was able to access it, but they're having issues and they have to have a Monarch login.
Okay. That link is supposed to be open. Let me ask you, was that Carrie?
Yeah, this is Carrie. So I'm an ODU student. So
okay, Carrie, do you have Professor Ayala's email?
yeah, I'll email him.
Okay, send him an email and ask him about that. And then just let me know so that if there is anything else that we need to do, then we'll tell them while we are here. Okay. And then I'll continue with the presentation because they'll be able to see me. They'll be able to see me and follow along anyway. So when we go into the material testing lab, you'll be able to see these three folders in here. We have the tension test, torsion test, and then we have in here a presentation that is about the civil engineering technology program. I have the material testing laboratory in charge, certainly being a civil engineer with a structural focus or expertise would make me more in line with what is happening in the material testing laboratory. Essentially there, we test different types of materials under different types of loading conditions, boundary conditions, loading condition, temperature conditions, and we test those materials to failure. Essentially, we like to break things in the laboratory. Pretty much in every test, we end up a test by breaking something. And so we're very interested in collecting data, in processing data, and in being able to derive conclusions from that, testing process. And that's essentially what we're going to be doing here today. So the first thing that I want to do is just browse through civil engineering technology and give you a little bit of an insight on that. And I don't want to spend a whole lot of time on that, but I certainly want to be able to tell you what we have at the university in the engineering technology program. So you should be able to see now the CET PowerPoint presentation. And essentially what we have in here go this way. What we have in here essentially is the agenda. So the welcome message, which we have already talked a little bit about. What is civil engineering technology, the accreditation of the engineering program, the application process, and any contact information. This document is in the folder. You'll be able to download this information and review it at your own time. And if you have any questions, there are emails in there where you can essentially go ahead and write an email, send your questions over, and we'll be more than glad to discuss that with you. So here, what we have is one of the best shots, I would think, we have of the campus, a very large university. It's like a city, if you think about it, because it has all of the buildings spread all over a large surface area. And this is the heart, essentially, of the university. I call it a quad. I call it a quad, like a quadrant, because at my former university, we had one similar in Illinois, and it just looked like it. This giant center, green pad. And usually in the fall, when we do the welcome of the students, we have thousands of students in this area with tables and organizations and clubs and everything. So it's extremely exciting at the beginning of the year when the students return to campus. So I just wanted to show you that picture so that you can see a little bit about the university. So we are in REYES, and you know what REYES stand for. This presentation is specific about civil engineering technology, or at least this particular file that I have in here. And that's my contact information. And if you download this and you click in there, you can actually see my LinkedIn page. And I would certainly love for you to follow me on LinkedIn and stay in touch. If you have any questions about anything, just contact me. So feel free to click on the link later on and send me a request, and I will be more than glad to accept the request. So civil engineering technology is a branch of engineering technology that deals with the analysis, design, and maintenance of the infrastructure system. This is essentially everything that we have out there: roads, bridges, buildings, towers, dams. I mean, everything. Infrastructure is literally everything. I would be biased in saying civil engineers would rule because we do everything that people use. As far as, you know, certainly we need other disciplines as well, but I will be a little biased on that sense. The infrastructure encompasses everything that surrounds our environment. Like I was mentioning, roads, buildings, bridges, towers, tanks. What I call buildings and non-building type structures. Non-building type structures are not occupied by people, like towers or dams, where our buildings are occupied by people. So we have those two distinctions in there. The curriculum includes general education courses, mathematics, chemistry, physics, fundamentals of engineering courses, and the discipline courses. The discipline courses are essentially the ones that are going to teach you how to design, analyze, and design all of the infrastructure type structures. The average completion of the program is 4.5 years with the margin of error of 0.5. And that all depends on whether you are a full-time student or not. We work with the students in the program. Full-time students, we have part-time students, we have military students, pretty much everything. We have students that are on campus, students that are online, everywhere, literally on the globe. So what is engineering technology? Is project-based learning. So that means that we would work on a project, and as you do the project and you have the requirements of that project, you are actually learning about the mechanics of it. So that's why we call it a project-based learning. And practice-oriented instruction, which means that the problems that you do here are very similar, if not identical, to those that you would do in the industry. So they are not necessarily book-type problems. They are practice-oriented type problems, which would make more sense. That's why engineering technology is known as a practice-oriented degree. The math and physics that we have in the program is consistent with industry needs. So we prepare you with exactly what you need to be successful in the industry as far as mathematics and physics. And the program is accredited. In the United States, accreditation is extremely important for the public, important for the employers. And the accreditation essentially is an assurance that we have the capabilities and the resources to be able to prepare you to become an engineer at the end of your career and to be able to join a company and be successful in the company. That permits us to prepare you, that accreditation. And it also allows you to sit down for licensing. In the United States, we require engineers, graduate engineers, to sit down for licensing if you are interested in approving projects for construction. And that may need further explanation. So if you have the license and you are interested in approving projects for construction, then you can do so. Nobody without licenses, engineering licenses in the United States can approve projects for construction, and that is a safety requirement. So licensing is important, and it opens the doors to many things in your career. Engineering technology is also online. It's on campus and it's online, so you have flexibility. And it is a robust program. It certainly challenges you and prepares you for what's ahead. The academic program is called a Bachelor of Science in Engineering Technology with emphasis in civil engineering technology. Then you can go into a concentration. And those concentrations are listed here in the bottom right corner: structural design, construction management, and site development. So just briefly, a structural design or structural engineer is one that analyzes and designs the skeleton of the structure, what supports the structure vertically and laterally. That has nothing to do with how the building looks or where the building is located. It has to do with the stability of the structure. The structural engineer is responsible for the stability, vertical and lateral, of the structure. That's really the function of the engineer, the structural engineer, in determining the forces, in sizing the elements, and providing the necessary materials to accomplish that. The building that you are right now was designed by a structural engineer. The construction management person deals with the planning, the organization, the scheduling, the estimating of the project. So that is a very important aspect of the construction, if you will. Planning, construction, estimating, management of the construction project. So that is a lot of organization in there. And the site development concentration is the engineer that deals with the preparation of the land, the ground, before any construction takes place. What happens on the site before anything takes place? Who decides how to level the ground? Who decides where the roads are going to be located, where the water lines, where the sewer lines, where the electrical lines, where everything is going to be located on the ground? The surveying that is done on the ground, the mapping of the ground, the site development person works with the ground level before anything takes place. So it's a very important aspect. It's a very important engineer. And so we all complement each other. We all need from each other. So that, in a sense, covers what we can offer here in civil engineering technology. The courses are structured in 100, 200, 300, and 400. The first bullet point, 100 to 200, is what we will consider a 2-year degree, an associate level course. 300 and 400 are bachelor level. Those are the last 2 years. In the United States, we would classify the student in the following categories: freshman, sophomore, junior, and senior. Those are first, second, third, and fourth year. That's how you would literally, in a conversation, talk to a student and say, "Hey, what standing are you?" "Well, I'm a junior already. I'm in my 3rd year of education." So that's how it's classified. Many of you are already familiar with this. Certainly, this is just a presentation to provide that overall. The program strengths accreditation since 1976. So we have been doing this for a long time. And so the accreditation, which is extremely important, we have had it for a long time. Most faculty have relevant professional licensure and or certifications such as PE and LEED. So in engineering technology, you will likely see a lot of people with the license because for the most part, we came from industry before becoming a faculty member, which was the case with me. I was 12 years working in industry before I became a faculty member, and now I have been here for a little over 11 years now. So the engineering technology faculty has a lot of industry experience. Also, engineering technology has a lot of experience with online distance learning, asynchronous and synchronous modes, as well as face-to-face, which is the traditional mode. When we have a diverse engineering group, we have people from all over the world, faculty members and students. And that makes you feel, that you are that you are not alone, that you are here with all of these many other aspiring students. The instruction is project-based learning. The instruction is applied practice as well. And we have state-of-the-art equipment in laboratories, which allows us to do all sorts of testing. And the department has a very strong focus on student retention and graduation. We want to make sure that you stay here. We want to make sure that you graduate. That is very important. Any other information related to civil engineering technology, there's a web page. If you click in here, it takes you there, and it has all sorts of additional details about civil engineering technology. This is just to let you know how many students we have in here. Oh, and I forgot to mention that engineering technology is the largest undergraduate department in the College of Engineering. When I mention that again, the largest undergraduate department in the College of Engineering. So that tells you that we are very successful in what we do in preparing engineers. So this is a trend of registrations since 2012. I actually started here in 2010. And so in 2010, when I started, we were about the same. So you can see that there is a lot of registrations in here all over the year. So it's very constant. That's the fluids mechanics lab, soil testing lab, material testing lab. That's what we're going to talk about today. And we're just going to focus on torsion. Computers lab, library. The library is enormous and it's very comfortable, has a lot of resources. Hey, there is no excuse for you to not to do well in the program. Athletic facilities. And that's a little postcard about the program, etc. Accreditation since 1976. I'm going to just browse a little faster in here. Application process. Just click on the different links and you can find that information. Undergraduate admission, transfer admission, and that could be your diploma. So keep that in mind. Contact information at the end of the file and emails. So feel free to communicate. So I'm just going to remove that and go to the torsion test. And when we go to the torsion test, then you'll be able to see a number of folders in here. We got a torsion presentation and we got a lab overview. So we have one lab overview. We got two equipment setup, equipment and specimen setup, and three low alloy steel test. So we have those three things. Those are videos, and some of them, they last 10 minutes, and some of them, they last a little bit more, but they are not really that long. So you may spend about an hour watching 1, 2, and 3. And so that is me in the laboratory running the test. So I want you separately to click on each one of these things in order and go over what is being explained and the data that is provided. And so the equipment that we're going to be using in there is a torsional machine. It's a 10,000 pound torque machine that essentially twists this bar, and we're going to collect the force that is being applied and the angle of twist. And then with that information, we do other mathematical study. And that's what I want you to do, some math in here. So we do the equipment and setup for the test, and then we test low alloy steel in torsion. So do everything in numerical order. So we start here with the presentation, and then we move to a number of questions. Who takes the laboratory? What is torsion? What are the examples of torsion in the real world? What are some of the materials? What are the mechanical properties? What equipment is used, etc. So we have this number of questions, and at the end we have a homework. So here I am introducing you to this online class. I'm just giving you the tools, and then I want you to go separately and follow numerically those 3 videos in order, and then complete the homework. Now, let's talk about what is happening in here. So we have in goals and objectives, understand concepts related to torsion of metals. So we are essentially twisting a bar, and this bar is solid. It's a round, solid bar. We want to study the mechanical properties of metals in torsion. We want to potentially research online. If you have questions, you research online, and you find information that may help you understand things better. We apply concepts learned here to collect and process data. We develop a graph that shows the behavior of metals in torsion. So if we twist this bar, are we able to plot a graph and see what is the behavior of this material? The answer is yes. And then we want to interpret the results and derive conclusions. So what do we learn from that graph? So this laboratory is taken by civil engineering technology, mechanical engineering technology students. Certainly, the engineering side, and that may be something that some of you may be new, we have engineering and engineering technology. Engineering is science and theoretical based. Engineering technology is science and practice based. But this particular laboratory is taken by civil engineering technology and mechanical engineering technology students. There is a little variation in the materials lab for engineering students, which is more science and theoretical based, certainly. So what is torsion? We have a bar that is round. The bar is subjected to a torque. You see this double arrow vector in here at the end? I want you to do the right-hand rule, where the thumb would be parallel to the vector. Double arrow vector is a twisting force. It's a twisting force. So if this pen is the bar and I am applying torque, then I'm going to twist. I'm going to twist this bar. I'm going to apply a torque. The right-hand rule would show you that. So the thumb is parallel to the arrow in the direction of the arrow. You see that this arrow in here is on the opposite direction. So then that one goes this way. And the one on the right side is the opposite. So if I apply equal and opposite, I'm twisting the bar, correct? So there is length L, there is diameter, D, and torque, T. The units of torque are units of force, and length in a genetic sense. So in the English system is pound-foot. If we were talking about the metric system, then we could use Newton meter. So we would say in genetic sense, force, length would be the units of torque. Examples of torsion are when we are removing the tire, the nuts on a tire because we have a flat tire. You see how familiar we are to torsion. Look at this traffic signal is mounted on a post, but this traffic signal is a cantilever beam. So there is a moment connection in here, and there is a fixed connection in there. If this mast arm moves in or out, up or down, is going to generate torque. It's going to generate torque and bending. So it has combined axial, bending, and torsion. It's a very interesting system. Those are examples of torsion. Materials that can be tested: alloy steel, aluminum, brass, bronze, fiberglass, stainless steel, cast iron, carbon steel, even plastics can be tested in torsion. We have literally several types of materials, and we as an engineer, we would like to evaluate these materials to make sure that everything works fine. The properties that we derive are modulus of elasticity, yield shear strength, ultimate shear strength, modulus of rupture, ductility, and torsional rigidity. Looking here, another example, when we are screwing a screw in torsion. When you apply that force to screw this fastener, you are applying torsion to it. That's the 10,000-pound Tenius-Olsen universal or torsional tester. You present the bar in here. When you watch the videos, the 3 videos that I mentioned earlier, you're going to see all of that process. One side is fixed, the other side rotates. This side is fixed, this side rotates. And as that is happening, is measuring the angle of twist and the force. Another example of a structure that is subjected to torsion, the round drive shaft of a vehicle. The engine is in the front, the transmission is connected to the drive shaft, and then this is connected to the back axle, and then your tires spin. That is another example of torsion. This pipe in here, or tube, transfers torsion so that you can actually move the vehicle. So this is nothing new. We have been doing this for a long time. The math that is needed. So these are all of the equations. This is gamma, modulus of rigidity, or shear modulus, G. And these are the definitions with the units. And the units that I have in here are in English. So use English. If you're familiar with metric, certainly yes, but remember one thing. Engineers have to learn both English and metric. Polar moment of inertia, torque, shear stress, shear strain, modulus of resilience, modulus of rupture, angle of twist, torsional stiffness. So you have all of these equations. Each one of them have variables. Those variables are associated with the figures. That's the shear strain, the gamma. Look at the angle of twist. The angle of twist, theta. Those are Greek letters. The diameter D, the length L. You see these arrows in here represent the twisting force. So we have equations. So those are the mathematical equations you're going to need. Variables, diameter, radius, shear stress tau. This is the Greek letter tau. Shear strain gamma, and so forth. The units of the different variables are provided here. That's the bar that we're testing. Is a solid bar, radius R, diameter D. Difference between theoretical and experimental, which is something very important in here that I want you to think about. So we mathematically can predict the stress, internal stress, that is in a bar that is subjected to torsion. But can we test in the laboratory and predict at which force the material is going to break? So one is a pure mathematical example or problem, and the other one is a pure experimental problem. So we predict how much it's going to take, force is going to take to break it. We can test exactly how much force is in fact going to take to fracture. So that is the difference between the theoretical and the experimental, both very important. And once we know with certainty what the equations for predicting are, then we can design safe and economical structures. So you see how we can tie these two things. So collecting and processing data. So when we're doing experimental work, we are going to record information that is going to be necessary for us to understand what is happening. The force that is being applied to the bar, the angle of twist that is being generated as I am applying this force. So those are intervals that I am applying. So we apply this force in a gradual sense, and then we let it, we let it behave and see how it's going to react to these forces. We collect this data and we prepare an Excel file to organize all of this data. We want to organize the data. So read the bullet points carefully, and this is the homework that I'm going to ask you to do. So you're going to reproduce in Excel the format provided in the figure. You're going to collect the data from the videos. You're going to enter the data in columns 2 and 3. You see that I put a number in here, 1, 2, 3, 4, 5, and so forth. And so plot torque versus angle of twist. Define the equations in Excel for columns 5 and 6. Plot torsional stress versus torsional strain using the mathematical equations that were presented earlier. So you're going to need this file to do the homework that has been presented. So there is a challenge in here because I'm not really providing, let's say, examples. Many of us say, well, I want to see example. I want to see example, a numerical example. I'm going to let you loose with the information, and you'll be able to watch the videos, and you'll be able to work the assignment. What I am going to do before we start going into some questions in here. Is okay. That is my email. I sent it in the chat. That is my email. If you have questions about this homework, feel free to send me a message. And right now, if you have any questions, please ask any questions. We have close to 10 minutes or a little less than 10 minutes. And we'll be able to discuss. But if we run out of time for any reason, please send me your questions by email. So you should be able to see on the screen lab overview. So you're going to essentially click on the icon, play the video, and collect, information. I'm going to essentially there be introducing you to the equipment. And then on the second part, when you click in here on number 2, it's going to take you to another video. You click on it and you're going to follow that video as well. And then on number 3 is the actual test. On number 3 is the actual test. And then here, you click on it, and then there's another video. Click on it, and then you watch it, collect the data, and use the Excel. Excel is one of the best softwares out there. Use Excel to do the homework. The equations that you need are all in the presentation that is here at the top in the material testing lab folder. Let me know if you have any questions. I would say that it will take you about an hour or so to go through 1, 2, and 3, the videos. And that will give you an idea of how the virtual labs are done. Now, that laboratory in there, we have simplified a little bit for this presentation, but in the real class, we would test more materials. We could test, 3 different types of materials. When we talk about tension on the next class, then we'll be able to see other materials being tested. Okay, so where do you submit the homework? Yes, very good question. So submit the homework by email. Use my email to submit the homework. Okay. Let's go here. I'm just going to send it in the chat. Okay, so I just send it over the chat, and take take some time. Usually we give a homework during a week time format. that will be the time that we would allow students to do a homework. Now, in a laboratory, you will also have to prepare a report. I am not really asking you to prepare a report, just answer the questions that were on that presentation file, those specific questions. So you're essentially developing two graphs, is all that you are doing here. So our laboratory actually has nine experiments. We do a verification or calibration of testing. It's called verification or calibration of testing, which is one of the experiments where we essentially test whether the equipment is adequate, is actually applying the loads that is saying that it is applying, where the equipment is measuring the deflections that is measuring. Okay, so I have a question here. It says, do you get a special prize when you submit the homework? Well, certainly I will send you a nice email with the recognition that you were one of the people that solved it. And I can tell you that in years past, I have had very nice surprises of students from different parts of the world completing the homework very well. And so I would certainly recognize that and reply back to your message, to your email. And we'll stay in touch, definitely. Again, follow me on LinkedIn and we can stay in touch. And I'm always open for questions. I was actually an academic advisor for 8 years. I was a director on a program, but for 10 years, actually, I was an academic advisor. So I can talk to you about anything related to education. Any questions that you may have, we can discuss. Certainly my area is engineering, but I will be able to help out. Okay, so I think we are running out of time. Oh, and I was telling you about the experiment. So the calibration of testing, we do compression and bending of wood. We do compression and bending of concrete. We do shear strength of fasteners. We do non-destructive testing. We do fatigue testing. We do harness testing. We do impact testing. I mean, we do a bunch of experiments in the laboratory, and that allows you to to see and learn mechanics. Okay, so there is another question in here. In today's Torsion Spanish class, are we going to see the same topic? Yes, we are, but we're going to talk, everything is in Spanish. So if English is not your first language, certainly in Spanish, you'll be able to catch, you'll be able to catch anything that you may have missed from the English presentation. But we will essentially talk about torsion. So that's pretty much what we will do. So we are out of time. It was a pleasure talking to you this morning. Go through the Blackboard material testing lab in numerical order 1, 2, and 3. When done, submit the homework. Let's see who accepts the challenge and make it happen. Thank you so much.